Hello viewers, welcome back to Snap's Let's Learn Academy. In previous lecture we have discussed user and operating system interfaces. In this lecture we will understand the system calls. The system call provides the interface between the program and operating system. So therefore the system calls which provides the interface to the services which are made available by an operating system. So whatever the services are available by the operating system, all the services are called by the system calls. In the second lecture of the operating system, the basics of operating system, we have already discussed what is system call, monitor call or system call. You can go to that lecture and just go through the content of the lecture. You will understand the system call. So system call which provides the interface to the services which are made available by an operating system, and these call means these system calls or system services calls are generally available as functions, and these functions are either written in C or C++ kind of high level language, although there are low level tasks may have to be written using assembly language instructions. So some of the task has been written in assembly language, and we may prefer the high level language such as C, C++ also for writing the functions for the system calls. Okay, let us understand by this user mode and kernel mode. You will be getting more clarification about the system calls. As I said that the system call provides an interface to the service made available by an operating system. So there are user mode and kernel mode. We have two modes in which the computer processor operates. So computer processor operates on user mode and kernel mode. So both user and kernel modes are the computer processor operating modes. The processors, if you have a single processor, then we say processor, or processors means multiple processor, either single processor or multi-processor system. If you are using, the processor switches between these modes depending on the code being executed. What code we are executing, based on that our processor changes these two modes or switching between these two modes, user mode to kernel mode to user mode. The main purpose of the user mode is where the applications gets run. All the applications like compiler, assembler, database, word processor, spreadsheet, text editor. So all these applications run in the user mode, and this user mode has limited access to the computer hardware and its resources, because user mode or the applications cannot directly access the hardwares. Kernel mode can access, but direct access is not possible in the user mode, because applications run in the user mode and applications have a private virtual address space and they handle the table also. So user mode applications can only interact with privileged hardware through the system calls. So by getting the system calls, right, system calls or the services which are made available by the operating system, in user mode, whatever the applications we are using, those applications will be getting some of the privileged hardwares, not all the hardwares, some of the hardwares by some of the applications. By requesting the operating system, we can get the services of those privileged hardwares, right? If user mode applications run in isolation, so if one crashes, it doesn't affect the other application. Means we are having the multiple application. If one of the application get crashed, then it doesn't affect the other. It doesn't affect the other application because it runs on the user mode, and whatever the applications run on the user mode, so that doesn't affect the other applications and hardware. When it comes to the kernel mode, it is this kernel mode is called as the core. It is a core of the operating system. So kernel mode is the core of operating system. So you can say the heart. It is a heart. Kernel mode is the heart where all the components of the operating system runs. So therefore the kernel mode is called as the core of the operating system. It is a heart of the operating system, and this kernel mode is responsible for managing the system resources and hardwares. Being a heart of the operating system, it is a heart's responsibility to take care of all the resources and the hardware, including the task which includes the process scheduling, memory allocation, device management, etc. All these tasks is handled by the kernel mode, not by the user mode. So all the code running in the kernel mode share a single virtual address space. So this is how the kernel mode and the user mode works in the system calls. Hope you understood all these concepts which runs in the user mode and kernel mode, how this user mode operates and kernel mode operates. Okay, as far as whatever I have explained right now, so programmatic way in which all the programs request the service of the kernel. So the kernel is responsible for providing all the resources hardware to the user mode. So user applications run in the user mode, and those application, if one of the application fails, it doesn't affect to the kernel mode, right? Now let us have the example of a system call where we have a sequence for writing a simple program to read the data from one file and copy them to another file. Now I am using a cp command here. The cp is the copy command of the Unix operating system. Now the example is I am using a system call sequence. So I am using n number of system calls. I am not using a single system call because system call sequence. So I am using a sequence of system calls. With the help of sequence of system calls, what I can do is I can simply writing a program to read the data from one file. I am reading the data from this in.txt file and copy them to another file. So whatever the data I am reading from this in.txt file, that has to be copied into another file called out.txt. So how I am writing the command? So cp, that is the command of the Unix, copy command space in is the file name, .txt is the extension name, one more space, out.txt, out is the file name. So I am creating one more file, out file, to copy the content of the in file into out.txt file. Now this command copies the input file, right? The input file in.txt to the output file out.txt, right? So we are using the cp command to copy the input file content to the output file. A second approach is for the program to ask a user for the names. So I have already referred in and out. You can refer other names also. In an interactive system, this approach will require a sequence of system calls. First, to write a prompting message on the screen and then read the data from keyboard and characters that define the two files. Now, let us understand a sequence of system calls. So, here is the example of how the system calls are used. Now we have source file, that is, as per the example, we have in.txt file, and destination file is the out.txt file. Okay, now what we are doing, we are performing the operating system is performing a sequence of system calls. So how the system calls are used? Now let us take the example of system call sequence. Okay, so first of all, it acquires the input file name, that is in.txt, write the prompt to screen, so it will go to screen, access the input. So whatever the input is there, it is accessed and return on the prompt to screen. So we are writing the content of in.txt. Now what we are doing, you can see here we have performed one system call, second system call, this is the third system call we have performed, right? So far we have performed 3 system calls. Now acquire the output file name, that is out.txt. So fourth system call, which is acquiring or getting out.txt file name. Then write prompt to screen. So we are writing prompt to screen of this out.txt. Accept the input, whatever the input is coming to this file, accept it. Accept AC, okay, accept. Open the input file. Now open this input file, right? So we are performing the system calls. Open the input file. If the file doesn't exist, means in.txt file doesn't exist, abort means we won't copy the content of source file to destination file. So abort means cancel this task, abort, right? So cancel the task. Otherwise, if file exists, condition become false, then go to next statement, that is create output file, that is out.txt. Then if the file exists, if already out.txt exists, then abort it, means already there is a out.txt file. Before we are creating the out.txt, already in computer there is existing out.txt file. Don't get confused. Before writing this command, assume that there is already file out.txt, then this condition satisfies and it aborts the copying the contents from one file to another file. But in our condition, we are assuming that there is no in.txt, there is no out.txt. We are performing this operation of copying the content from one file to another. Now assume that the file exists. No, out.txt was not created by any user in the system. So first time we are creating it, assume that. Okay, so then we will move to the next statement. So condition is failed. Fail means we don't execute, we won't execute it, we won't abort it. Okay, we will move to the loop. Next statement is the loop. So loop it. Loop means perform the iteration. How many times? So there is a until read fails. This is the loop closing statement. Okay, so loop is starting here and it will end here if the condition satisfied. So start looping the file, read from input file. So whatever the content are there in this read from input file, in.txt is having these many lines, 6 lines, assume that, right? So read from input file, read the first line, write to the output file, write this first line to here, second line as usual, third, fourth, fifth, sixth. How many lines were there? 6. So 6 has to be right here until read fails. Next, when we go to the prompt, we won't get the next line here. So we don't have the 7th line, means read fails. When read fails, a loop get terminated, then close the output file, then close this output file. Okay, write completion message to screen. On monitor screen, print the message that write completion. So copying the content is completed, right? Then terminate normally. So these are the sequence of system calls. Let me take one more example. Assume that if you are copying the content from one drive to another drive, for example, say from D to E, if you are copying your file or folder, what's happen? You will be getting one progress dialog box on your screen. It will show you the progress, how much percent it is copied the content. So it will show you the progress. Once this 100% progress completes, all the files from D to E is copied. It will show you all the files are copied. That is write completion message, and the termination take place. So normal termination take place. So this is how this system calls being generated for this example. Hope this example is understood by you. Okay, right. So assume that when we perform the system calls sequence for writing a simple program to read the data from one file to another file, then instead of writing the cp command in the Unix, copy command in the DOS, cp in Unix, copy, copy command in DOS. Assume that we are using GUI environment. So both these commands works on the CLI environment. We have two types of environment in the computer. One is CLI, another one is graphical user interface. In previous lecture, we had already discussed these two environments of the operating system. Either operating system works on the CLI environment or GUI environment. In the previous lecture, we had discussed all these, both these CLI and GUI environment. In GUI, we had also discussed touch screen also. Nowadays, in mobile tablets, we are using touch screen GUI environment. So that third approach of the interface of the operating system also discussed in the previous lecture. Now assume that on mouse based and icon based system, means we are using GUI system, the menu of file names is usually displayed in the window. So menu of file names. So in window we are getting file names, right? The user can then use the mouse to select the source name, and a window can be opened for the destination name to be specified. So we can specify a source as well as destination. This sequence requires many IO system calls. Even simply we are just right clicking, copying the content, pasting it, Then also it requires a sequence of IO system calls. Right. So this is the graphical user interface mode where the mouse based and icon based systems are used to copy the file from one place to another place or one drive to another drive. As I said, from C to D, if I am copying, so I will use the mouse and I will just copy the content of the C or files of the C drive, and then I will paste it into the D drive. So there also I may require a many IO system calls. Right, so this is all about the system calls. Hope you understood all these system calls. So like, share and comment. So thank you for watching.